Okay, hello everyone. It's time to start today's training. I'm Devon, and welcome you all to attend today's training. Today's training is about the data process by using Lua script and VB script. And for better presentation, I use arithmetic operations to introduce how to use this script to analyze and do some operations for the data we get from our HMI and RHV box. So let's begin. This is a very widely used script in our HMI and VBox. The first part is about the macro script. It's also known as a VB script. So when we use this script for getting the data and to make the calculation, this is the workflow of the script structure. The first part is to get the integral values. If we do the integral values calculation, and then the second part is to use the add or subtract to calculate the integral values. And then the last part, when we get the result, we need to set the result to the variables in our HMI. So let's see this presentation. Forget the integral values. So here we use D2F functions. This function is to convert the 32-bit integer float data to float, then output the results. Of course, there are many more other functions can get the integer values also, but here I just use this because it's not only to get the value, it also to convert the value to the floating point data. So the parameters of this function is two. The first is the required data. It can be an address or other variables we identified here. As you can see, I identify the variable as a floating variable. And then the second parameters is for the resource data. It begins with at. For example, we want to convert the double word from HDW100 to float and save it into A1. So we use A1 equal D2F. A1 and at W underline DHW100. And we can also do the same for the other variables, but just here, and save it into a B1 variable. And then for calculate the integral values, we use this script. And please note for the division, we need to use if then structure to avoid the number divided by 0. And then the last part is to set the integral value. So here the result is the 32-bit floating data, so we need to convert it into the integer format and then output the result. So here I use another functions as f2d, floating number to integer data. Also is the two parameters here. For destination, the first is the destination. We use @w_hdw104 to save the data. And the second parameters is the resource data. Also can be a address or a variable. Let's see the program here. So here is the project screen for integral calculation, and I use the background script by double click here, and I trigger the script. It's a little small here. For the beginning, we can, if we want for a timing to trigger every cycle, double click timing, and we can set the script name and the interval time. And please pay attention, the unit is 10 milliseconds per cycle. So here if I just enter 1, it means the script will execute every 10 milliseconds. If I enter it as 100, it means the script will execute every 1 second. And this is the script for addition, subtraction, multiplication, and the division here. The structure for different operation is the same. The only difference is here. Use if and if then. So let's see how this demo works. Please pay attention to here because it's calculation based on integers, so the result here is not 2.5, it's only 2. And we can check this program. Here all the address, I set the data format as 32-bit signed all of them is the same. Of course, there is other functions can do the same. As you can see it here. So here I identify the variable as integer, and I use another function signed int 16. We can check this script in our Wacom Support Center. Yes. So this function is assigned the variable from the address 1, which is a signed integer. So this is the example here. To set the value of variable a the same as DWH0, and then assigned DWH2 registers equal a to assign the value a to DWH2 HDW2. So here I use it as a 16-bit signed address. And then it's also the same if even this is a minus number, it can still work normally. And if you want to change it a multiple b, so 5 multiple 9, and we get a result is 45. So what type of function we use is based on the data format. Please pay attention to this. Do you have any questions about this part? Okay, so let's move on to the second part of VB script, is to calculate the floating number. The what follow is also the same. The first we need to get the floating number from the address, and then we use the add or sub to calculate, and then finally we get the floating number result and set and convert it into the result registers. So here for getting floating number value, I use function named d2float. So this function convert the designed value to floating, then assigned to the variable. The structure is similar to the d2f I introduced. A1 is the resource data. So here I use the HMI register address here. And the F here is user-defined floating variable. Before we use this variable, we must use this language this script dim, so the variable name as floating. And for calculating, actually this part is the same as I just mentioned. And then the last part is to set floating number value to the registers we need. So here the function is float to d. It's for copy floating value to the address. Also, it has two parameters. The first parameter is for the goal address. Start as at w underline hdw. So here 104. So 104, just 4. And the second parameter is the resource data, the variable. So let's check this program again. For the floating calculation page screen, now I identified it as the data format is 32-bit floating, different from here. So now when we calculate 55 divided by 22, we can get the value 2.5 here, not 2 also. And here is also support to calculate addition and subscription, multiplication here. Okay, do you have any questions about the usage of VB script to get and set the variable number or adjust number? Okay, so let's move on to how to make the data process by Lua script. Actually, for the moment, we are more recommended to use Lua script because it's more flexible to meet different requirements. So we can still use this workflow. The first, when we process the integer value, we need to get the integer value first. So here I use the function as we underline bas underline get short. Short here means a single word signed decimal here. Single word at 16 bits. So here is the demo script here. Local A1. So we identified a variable as named A1 and equal we underline base underline get short. So here we use at w underline hdw0. So the value of register HDW0 will convert to A1, and it's also the same for the value of HDW10 will convert the value to B1 here. And then for calculating, here is integer number. Arithmetic operations, the script is also the same, but different here is for C4 here, we need to use local to identify the result variable. Also to avoid B4 is 0 to make the division calculation. So when we get the result after the calculation, we need to set the integer values to the registers we want and display it in our HMI. So here we use WE underline BAS underline S set short. Based on the data type you use, so we calculate a single word signed decimal, so we still use short here. And this function has two parameters. The first is for the address we want to display the value, and the second parameter is for the data resource. So maybe you have some questions. How about use other different data type? For example, unsigned decimal of 16 bits or 72 bits. So here is the table to match the different type here. If you use a single word unsigned decimal, you just get word or set word. If your data is 32 bits signed decimal, you use int, get int or set int. And for the 32-bit unsigned decimal, just use get D word and set D word here. Don't make a mistake here to use get word also. D means double. Yes, because today's training is about the calculation. So if you want to process the stream type data, we can check it in our support center here. Also, if we process the stream data, you can see there is another parameters for the length. With base is just for sorry. not showing in this page. You can use ADDR also if you don't use VB underline BAS. It's also the same. This part of this part is the same. So read or write. Okay, let's see how this demo works. So here the first part, I also to set all the address here as 16-bit signed value. And it's also the same for the integer calculations. The result can only get 4, not 4.6. I didn't test, but I think it's the same. We can test here. Yes, it still works. Okay, do you have any other questions about this part? Okay, let's move on for the last part about the floating number calculation by the Lua script. Also the same workflow: get the value, calculate the value, and set the value. So here I use a 32-bit floating number as example. So here I use the function as WE underline BAS underline get float. And it's just one parameters for the value of registers we need. The for register we want get the value. And it's also to calculate by the same script. And then for the last part is to set floating number value. So you can see all the set and get the value script structure is the same. First parameter for the address to store the value, and the second parameter if the value resource. So sometimes we get the value from other device, and it's 64-bit floating. So for that case, we use get double or set double to read and write 24-bit floating number. Okay, so let's see the floating calculation part. The similar structure as the integer calculation. Okay, this is a demo project. As you can see, also a support. By this way, we also support to calculate for the minus value. Okay, this is all for today's training about data process for arithmetic calculation. Do you have any questions about the last part? Okay, if you have any other questions, you can leave your message in our training group. Function is the function right salary. Yes, the function you write here. The function you write here will execute every time when you in this screen number. Okay, let's continue for the last part of today's training. Is also a mini lucky draw, and today's gift is different. It's a fridge, magnetic sticker. So please notice that after pass the final exam and the prize and the certificate will be shipped together. So it's necessary to pass the final exam. Okay, let's welcome Miss Mori to conduct today's mini lucky draw. Okay, congratulations to this lucky person. And this is all for today's training. For the last, please do remember to submit the after class exercise to our support01 email. And if you've failed to submit the after class exercise more than twice, it's not allowed to pass the final exam. So please notice that. Okay, that's all. Bye bye.